Hi everyone, welcome to this new lecture of Engineering Economics. In this lecture, we'll discuss about measurements or methods of price elasticity of demand. In our last few lectures, we are discussing about the elasticity of demand, and this lecture will see what are the methods of price elasticity of demands are available. So actually, there are different ways we use to calculate how much quantity demanded of a product changed in response to the change its price. That means what are different methods are available to calculate that based on that how much quantity demanded of the product changed. So the quantity demanded products changed with respect to in response to change in price. So if the price of the product is changed with respect to that, how much quantity demanded changed, that will identify by different methods. So there are basically four methods are available. The first one is total expenditure method, also known as total outlay method. Second one is percentage, or also called as proportionate method. Third one is point elasticity method. Fourth one is arc elasticity method. So these are the 4 points now we'll discuss. The first one is total expenditure, or we can say total outlay method. In this method, actually, we will find out the price elasticity of demand. This method actually basically identified or developed by Alfred Muscle, and this method measures the elasticity by observing the how total expenditure changes when the price changes. So the total expenditure, how it changed, that we can identify when the price is changed. And in this method, actually, we'll calculate the total expenditure. We'll find out the total expenditure of the we can say the product, or any kind of we can say the warehouses, anything you can say. So for to calculate the total expenditure of that, we need to consider the price of the product. Also, we need to consider the quantity demanded, how many. So price of the product is P and quantity demanded need to be considered the Q. So this again, it is categorized into 3 different types. The first one is elastic demand. Elastic demand is actually when the value of ED, or you can say the elasticity of demand is greater than 1, then we can say that is elastic demand. So in this condition, actually, when the price decreased, the total expenditure increased. This is first point. When the price of the product is decreased, the total expenditure increased. Second condition is when the price of the product is increased, the total expenditure decreased. Reverse to this one, vice versa this one. Or here we can say also when the price falls, the total expenditure rises. So there are 3 different points are there. So that we'll see in the graph, as well as one example I have taken here. Suppose one price of the product is given 10 rupees, and when it is decreased from the price 10 rupees to 8 rupees, actually when the price of the product is 10 rupees, at that time 100 quantity was ordered. For that 100 quantity order, total expenditure how many? The P into Q. So P of the P is this one and Q is the quantity. So P into Q, the total expenditure, that means 1000 rupees here. But when the price of this product decreased from 10 rupees to 8 rupees, at that time the quantity ordered here 140, suppose. So what about the total expenditure? Again, we need to just multiply these two, then we'll get 1120. So this much expenditure is there. See, the price decreased here, and total expenditure increased here. Next thing is, if you see, when the price increased here, the total expenditure decreased here. Reverse, vice versa case in that. So the same thing if you plot in the graph, that we can see here. Suppose this is our y-axis here. In the y-axis, the price is given like a P1 and P2. Initially, the P1 is the price, and the price changed from P1 to P2 here, and the quantity that changed from Q1 to Q2. When the price of the product is at P1, at that time, this much quantity was ordered. Suppose price of the product is, suppose this is 10 rupees. At that time, 100 quantity was ordered here. So this is 100. Now you can plot this. This is our point here. Now the price changed from 10 rupees to 8 rupees here. When it decreased, the quantity order here it is increased how many? That is 140. So this is our second point. Now you can plot this graph. This is our demand graph. But what about this total expenditure? the total expenditure is increased. Now, if you see, when the price falls, the total expenditure rises. Now, the price falls here. So the price falls from here to here. Suppose this is the total expenditure at the first condition, and the total expenditure increased up to the TE2, from TE1 to TE2. So some examples we can consider in this. So when the value of this ED is greater than 1, now you can see this is the total expenditure for the first one. For the second one, this is the value. So here we will get the ratio, or the value of ED is greater than 1. Some luxury items or goods with many substitutes, if the price drops, causes the massive surge in the sales volume. If slightly the price decreased, there will be a massive change in the sale volume. The total revenue, or we can say the expenditure, can goes to higher level. So that is in the elastic demand case. The second one is unitary elastic demand. In this case, the value of ED will be equal. Okay, so demand is unitary elastic when the price changed or results no change in the total expenditure. Though the price decreased here, suppose same example I'll consider, the price decreased from 10 rupees to 8 rupees or 9 rupees. There is no change in the total expenditure. How much expenditure was there initially? Suppose 1000 rupees is there. Even for this 1000, even for this also, again the same 1000 rupees expenditure will come out from here. Okay. So the total outlay remain exactly the same regardless whether the price rise or fall. If you see, if the 10% fall in the price, so 10% fall in the sense 10 rupees to, it will become 9 rupees suppose, and it made an by an exact 10% increase in the quantity demanded, total spending remains unchanged. So 10%, and here also 10%, there will be no change in that. That's what it is told as unitary elastic demand, when the value of ED will get is equal, like unitary value, unit value, that is 1. So 10% fall, 10% here increase in the demand. The next one is inelastic demand. In this case, the ED value will be less than 1. So in this condition, actually, when the price decreased, the price of the product is decreased, the total expenditure decreased here. Again, when the price of the product increased, the total expenditure increased. In the previous case, it is not that. Here it can get the same thing. Like similar kind of examples also taken here. When the price of the product is, suppose $10 is there, and the price of the product is $10, the quantity order is 100 quantity, and the total expenditure here it is $1000. But when the price decreased from 10 rupees to $8, or $10 to $8, we can say the price decreased, the total expenditure decreased. How? The quantity was very less, it was ordered here, though it is increased, but there is very less number of increment is there in the quantity. At that condition, what will happen? The total expenditure will be less than the initial one. So what was the value of $1000 that cannot be able to cross by the second strategy? That's why it is less. When the price increased, the expenditure increases. Now see, if I go reverse, the price increased, the expenditure also here increased. So the same thing we can take in the graph. Here you can see the price decreased, the price of the product 10 rupees to $10 to $8 it decreased. And what about the quantity? Quantity also increased here, but total expenditure here decreased. The expenditure of the product is decreased here. Here we will get the same plot like previously how we got the plot. Here also will get the same plot. If you put this is a $10 and this is the quantity order 100, and this is $8, the quantity order here how many? 110. So the curve we can get it, demand curve, this one. But what about the total expenditure? The total expenditure here it is decreased. But in the previous condition, if you see here, the total expenditure increased, quantity increased here, price decreased, but expenditure also increased. But in this condition, if you see, your expenditure decreased here. So in the inelastic demand, when the value of ED is less than 1, then we can say it is inelastic, and the price and total expenditure, that both will be move in the same direction. Okay, so this will both will be move in the same direction. Some necessities item like foods and medicines, if the price of the essential medicine increased, the consumer still buy to close the same amount. It won't be decreased. Like initially how much amount was quantity was required, the same amount is going to purchase by the consumers, and forcing to spend higher total amount of money. That's why it is in elastic demand. The second one is percentage or proportionate method. In this method, actually, the elasticity will be measured by comparing the percentage change in quantity demanded with respect to the percentage change in the price. So here only you need to consider the percentage change in quantity demanded with respect to percentage change in the price. So you can write the ED value, you can calculate by considering this formula, ED equal to percentage change in quantity demanded divided by percentage change in the price. So that one you can write percentage del Q by del P. So percentage del Q you can write Q1 minus Q. This is new quantity, this is old quantity, and this is old quantity. Q1 minus Q by Q into 100. This is percentage del Q. Similarly, percentage del P you can write P1 minus P by P into 100. So we can write ED equal to, if I put this value in this, we'll get this equation del Q by del P into P by Q. So here also same thing, like P1 is the new price and P is the old price of the product. Now we will try to understand by taking one example here. So when the price falls by 20%, that means price dropped. This is the change in price. The quantity demanded increased by 40%. So demand in quantity increased to 40%, price fall to 20%. So we can calculate the value of ED 40% by 20%. You got del Q by del P, and here we'll get the value of ED equal to 2. So ED equal to 2 is demand is elastic. So sometimes you will get the value of negative. That value we need to ignore because the price value will be changed. Okay. So in that condition, initial price and final price, some minus negative sign, if we are getting in that answer, we need to ignore that negative sign. And here, how you can say the elastic value, like previously as I told you, that ED value will be greater than 1 means it is elastic, ED equal to 1 means unitary, and ED is less than 1 means that is inelastic demand, like what I told in the previous condition. The next one option is like point elasticity method. This is actually, it measures the elasticity at a specific point on the demand curve, like where the demand curve we are getting between the price and the quantity. At particular point, we need to find out this value. So it is mainly used to change its price when the change in price is very, very small. So for that, again, similar kind of formula will be used, ED equal to del Q by del P into P by Q. Thus, if you see the previous equation, similar kind of equation we got here. Here we got only percentage wise and, comparing the percentage change and percentage change in the price and demand. But here we need to find out at a specific point of the product, or we can the specific point in the demand curve actually. So here also same thing, the del Q is the change in the quantity demanded, del P is the change in price, P equal to price of the product, Q is the quantity demanded. If you are getting any kind of negative signs, so we need to ignore, because the price and quantity demanded generally move in the opposite direction. Both are in reverse direction, different directions. So this one we can calculate by two methods. The first one we'll consider by percentage method, like what we have done previously. Similar example I have taken here. Another one is geometric method is there. So in the percentage method, actually, let's identify the price of the product is 20 rupees and the quantity is 50 units quantity. And the price falls from 2 rupees, like means 20 rupees to change to 2 rupees, and the quantity increased by 10 units. So here you can see how much price falls. So to 2 rupees the price falls. So after price falls, what is the value will be there? 18 rupees suppose. So if you find out the difference, 20 minus 18, so we'll get the 2 rupees. That means that is the change of price. So change of price we can write del P equal to, this is 2. Similarly, what is the quantity changed here? 10. So here we can write similarly del Q equal to 10 here. So as per the formula, we can write ED equal to the same thing I have written already here, 10 by 2. So this is 10 by 2. And what about the value of P? Price is 20 and the value of quantity is 50. So if I solve this one, we'll get 2 to cancel, 5 is 2. So we will get the value of ED equal to 2. So 2 means the ED value is greater than 1. So the demand is elastic. The next option is geometric method. So for a straight line demand curve, the point elasticity can be calculated by this formula. What is the formula of this? Like ED equal to lower segment of the demand curve divided by upper segment of the demand curve. So for that, here also I have taken one graph here. So this is the graph given in the x-axis and y-axis. If you see, this is our x-axis given in the quantity, y-axis given in the price condition. So the graph what we got here, this is the graph what we got between the price and the quantity. Suppose at this point, as I told you, that point elasticity method, it will be specifically at a point it will be identified in the demand curve. So suppose here a point is taken, E point, and we need to find out the demand at the E point. Okay, so what is told, ED equal to lower segment. So in this graph, if you see, this part is our lower segment, E point to B point. This is our lower segment, and this is our E to A point, that is our upper segment. So the ED value will be calculated lower segment by upper segment. So we need to know the value here. What is the value for this point? So let's consider a straight line demand curve at point E, ED equal to EB by AE. Okay. Suppose the A is the upper segment and EB is the lower segment, already told. Let's consider AE value is 10 and EB value is 20. So either this value will be given in the question or you need to identify from the graph. So here ED equal to what? 20 by 10. So it got the value of 2. That's what. Here also the demand is elastic. So at the point of E, we got the value 2. And we can say the demand is elastic here. The next option is arc elasticity method. So this method is used to identify, to calculate the average elasticity of demand between 2 points on a demand curve. So what we have seen in the previously, this is only a single point. Now for this one, actually, we can find, suppose this is the graph is there, we need to check one point here, another point is here in the graph, it will be there. So that in that condition also, we can find out this is price and this is Q, and this is one point and this is another point. So it is used to measure the average elasticity of demand between 2 points. So this is one point, this is another point on the demand curve. And also it is used when a large change in the price and quantity. So we can write ED equal to the percentage change in the quantity demanded by percentage change in the price. The same thing, del Q by del P. But here we need to write P by Q initially we have written. Now we need to write P1 plus P2 by Q1 plus Q2. So P1 and P2 is nothing but the initial or original price, or you can say the new price respectively. P1 is the initial or original price, P2 is the new price. Similarly, Q1 is the initial and original demand, Q2 is the new quantity demanded respectively, that is. So let's try to understand by one example also. When the price falls from $8 or $10 to $8, the quantity demanded increased from 100 to 140. This is the same example in the first we have discussed. And then here we can find out what is the value of ED. So ED equal to, as I told you, del Q by del P. So del Q equal to what? Del Q is the demand change rate, 140 minus 100, that is 40, divided by the price change rate, 10 rupees, $10 minus $8. So we'll get 2, that is del P. What about this P1, P2? P1 is nothing but initial price and final price. So initial price is 10, final price is 8. Initial demand 100, final demand 140. If you add all these things, then you will get this value 40 by 220, 18 by 240. Now we can cancel this. This is 12. So 18 by 12 will get 1.5. So we got the value of 1.5 where ED value is greater than 1. So we can say this is elastic. The demand is elastic here. The next example is, suppose the price of the product falls from 20 rupees to 16 rupees. Simultaneously, the quantity demanded increase from 100 units to 120 units. So here also similar condition is there. Like same thing we are going to use here. What is the initial price? 20, final price 16, initial quantity, final quantity. So this is del Q. So here we can write like 20 minus 16. So 20 minus 16, we can write this is how much? It will be 4. And this is, okay, this is quantity. Quantity means 120 minus 100. That will be 20. 20 divided by, this is 120 plus 100. This is 220. 220 into P1 plus P2. So this is 36. 36 divided by P2 minus P1. So P2 is 16 minus 20. This is minus 4. So here we got the negative value. Then the answer also will get negative. So this one, if you cancel it, this is 11 and this is 9. So 9 by 11 minus 9 by 11. So if I divide this, we'll get a value of ED equal to 0.1818. So before that we got this value minus. So now we need to ignore the negative sign. As I told you previously, that both are moving in the opposite directions. That's why we need to ignore the minus value. So here we got the value of ED equal to less than 1. So that's what the demand is inelastic in condition. So these are the different types of methods of price elasticity of demand. I hope you understand this lecture. If you are having any doubt inquiry regarding this, you can give a comment on the comment box. Thank you.